Hello and welcome to the seminar on the subject PTSP, which is known as Probability Theorem and Stochastic Process. My name is Eluri Fanindra and I am going to give a topic called as Introduction to Probability, its definition, example, and the applications of the probability which we are going to use in real life. Probability distribution function is my topic which I am going to explain in this seminar. Discrete case and continuous case are there in this PDF. Probability distribution can be written in a capital PDF, while probability density can be written in small PDF. I can explain examples with the visual representation and one problem. Coming to introduction, the definition of probability can be given by probability is a numerical measure of the uncertainty. First of all, uncertainty means when we are going to measure the output of a certain event, there is some uncertainty which is known as the error or something noise or like that. We are going to measure that using the tool called probability. So simply the probability is a tool of measuring uncertainty. So such that we can estimate the outcome of the event nearly to the outcome. So there are many real life experiments like tossing a coin, rolling a dice, and uh, estimating the weather forecast, and also estimating the noise in the signals. It is very important application in the real life. So the probability lies between 0 to 1, which is a one property of the probability. Probability 0 means the event is impossible event. Probability 1 means the event is certain event. Certain event means it should be executed. So if the probability should not be less than 0 and greater than 1. Coming to the next. The examples are given here. Tossing a coin. So we know that tossing a coin gives us the outcomes head and the tail. We should not we may not be able to estimate one outcome at a time such that it is surely happens. So we can use probability to get the outcome. Also here in the dice there are 6 outcomes. Here also we can use dice. In the case of forecasting, weather forecasting, we can estimate the weather forecasting by observing the variations in the weather by drawing a plot, which is known as distribution. We can see here. Now coming to the topic probability distribution function. It can be defined as it gives the probability that a random variable takes a value less than or equal to a certain number. It is also called as a cumulative distribution function. I will tell you why it is also called as cumulative. The mathematical expression can be seen here. Fx of x equal to p of x less than or equal to x. The explanation is where the capital X is known as a random variable and the small x is known as a specific real number, which is a point we are checking for the probability. Now the capital Fx of x is the main thing which we call as a probability distribution function. Now we can see why and where it is used. Why we use PDF. It helps us understand how likely different outcomes are. It is used to calculate the chances of events happening within a range. Useful for predicting the real world events like coin tosses, game outcomes, or any measurements, etc. Like now we see the where PDF is used. In real life example, statistics and probability, we can use PDF there to study randomness. Also, it is used in data science or engineering, any other, etc. It's very useful in everyday life. Expression for distribution function. It can be expressed in two types. We know that random variable is of two types. It is which is in discrete nature and also in continuous nature. Discrete nature will look like this. Continuous nature will look like this. It can be any of the curves which it has a value for every particular point of time. Discrete nature is not like that. It has only values which has at specific points. See here, continuous nature has the value where the where we take the t value, we can get the amplitude value. But in discrete nature, it is available for only distinct values. Okay, now coming to the topic, let us see the expression for the distribution function in discrete case. Coming to discrete case, we already told that the probabilities are defined at the specific points only, but not continuous over the range. So the expression is given by fx of x is equal to summation I equal to 1 to n p of xi into u of x minus xi. Coming to the explanation, here we need to add the, for every value of I, that means the specific point, we need to multiply both the probability of that event and the multiplying it with the shifted version of the unit step signal and adding all of these, then we get the discrete case probability distribution function. So next, coming to the continuous case, for a continuous random variable, probability is spread over an interval. Like I told earlier, the probabilities are available for every point of t. So simply we can say that the distribution function is integration of all continuous probabilities of x up to the value x. Here we write that fx of x equal to integral minus infinity to x fx of t dt, which is what? It is a density function. That means the probabilities that are available in the range of some minus infinity to x and then adding it like a density. Here we can see the example problem. Here you can take the example of casting the three fair coins. Fair coin means the one side is head, the other side is tail. So x is a capital X is a random variable which we are taking the number of tails shown. So let us see the outcomes of the we get when we toss the three coins at a time. So the outcomes are these. We can get either three tails or three heads or one head, one, two tails, etc. So let us assign x1, x2, x3, x4 are the events for getting no tails, one tail, two tails, all the tails, etc. So we are labeling them as 0, 1, 2, 3. Now coming to the solution, we first to calculate it. We have to calculate the probabilities. So we can see here the probability of getting x1, which is no tails, is one outcome out of total 8 outcomes. So we get 1 by 8. So p of x2 is getting one tail out of these outcomes. We can see here there are 3 outcomes out of 8 outcomes. So we get 3 by 8. So getting two tails is given as we can see here, two tails, two tails, two tails. Out of 8, there are three outcomes which we need three tails. So now P of x4 is getting all the tails out of our outcomes, which is one only. So it is known as one weight. Which I am trying to tell you is the problem formula for the probability is number of favorable outcomes by the number of total outcomes. So total outcomes are same for all the probabilities. So now we need to calculate the distribution functions. As I told you earlier, the distribution function tells us the probability distribution for the value less than or equal to a certain number, which I have told you at the definition, which is probability distribution function definition, right? See here, a random variable that take a value less than or equal to a certain number. So we need to calculate this distribution for that problem. Let us calculate p of x less than or equal to x1 means the probabilities we need to sum up with the events which are x1 or less than the x1. There is no event which is less than x1, so we get only 1 by 8. So for fx of x2, we get p of x less than or equal to x2. There is one event which is less than x2, which is x1. So we need to sum up the x1, the probability of x1 and probability of x2. We know that p of x1 is 1 by 8, 3 by 8, which gives the sum 4 by 8. Also fx of x3, p of x less than or equal to x3. There are two events less than x3. P of x1, P of x2, and also we need to less than or equal to. So we need to add P of x3 also. 1 by 8 plus 3 by 8 plus 3 by 8 gives us 7 by 8. Fx of x4, which is P of x less than or equal to x4. There are four events totally which are less than or equal to 4. They are x1, x2, x3, x4. So we need to sum up all these and get one. We know that the sum of probabilities of the all events in a sample phase gives us 1, which is one of the property of the PDF. So coming to the distribution table, we need to arrange this table. For x equal to 0, the probability is 1 by 8, distribution is 1 by 8. For x equal to 1, the probability is 3 by 8, distribution is 4 by 8. 2, for 2, the probability is 3 by 8, distribution is 7 by 8. For 3, the probability is 1, distribution is 1. So we need to plot the graph here, which we are getting like for 0, the probability is 1 by 8. We need to plot on the x-axis, which is x value 0, 1, 2, 3, and on the y-axis, the distribution functions we got earlier. So for 0, distribution function is 1 by 8. For 1, distribution function is 3 by 8. For 2, distribution function is 7 by 8. For 3, distribution function is 1. The another property of the PDF is for the less than 0, there is no PDF exists. For greater than or 1, the 1 continues to the infinite, and 1, we know that the probability does not increase 1. So here the 1 continues like this. Coming to explanation, as we can see from the graph, the answer is 3 by 8 for the height of at the step 2, which is a cumulative sum of all these which are earlier to the event 2. So we can also call this as cumulative period. Coming to conclusion, probability isn't just a number, it's a fundamental tool for making sense of the uncertain world around us. We can also call the PDF as a PDF, which I shown here. We are adding cumulative sum of all the numbers which are less or equal to a certain number. So it is cumulative. Thank you.